Hi, everyone. This is the SEBA call for July 9th, 2019. What we have on the agenda today is a demo of the SEBA 2.0 alpha release. Saurav is going to be giving that. And just so everyone knows, all the meetings, the SEBA meetings, are public and recorded, and we do publish them to YouTube. So with that, Saurav, I'm going to pass. Do you want presentation rights?
Yes, please.
Alrighty.
Okay. Great. So thank you, everyone, for waiting around for this little delay. So let's jump straight in. So hopefully you can see my screen and also see me toggle through various screens, which I believe it's working. Okay, so let's get started. So what I have here is a pod with some of the standard SEBA software that is running. Especially as you can see, I have Volta running over here. We have etcd. We do have a Kafka bus. And the standard things that you expect, right? Lots of NEM services, as well as ONOS there. As you can see, it's running over there as well. So if you, let me right now start up a few things. I'm going to log into ONOS and look at the CLI. Whoops. I'm going to look at the devices. As you will see, there is one device over here, which is the aggregation switch. And there's another device that is mentioned over here that happens to be Volta, representing that OLT, but it is right now not connected, right? So we're going to bring it up as part of this demo. I'm also going to, normally I would have all this set up, but because of the delay, I'm just doing it all real time. So again, now I'm into the Volta CLI, and I'm going to look at the devices, and there's nothing over here as well. And finally, we have a couple of devices that you see over here. One says Iskratel, so that's this is an emulated RG behind the Iskratel ONU, and this one says it's an alpha ONU again. So this is an emulated RG behind the alpha ONU. So if I try to ping to the internet, of course, I can't get through. Nothing's really up. So that's the same situation over here as well. Okay. So I'm going to come back to that. Right now, I want to also show you the NEM interface that, if you're familiar with SEBA 1.0, you're familiar with this interface. Again, there are a few things that I do want to point out, okay? Right now, there's no OLTs or no ONUs in the system, okay? And this is one of the new aspects of SEBA 2.0. Now we have a tab called Technology Profiles, and literally there's nothing in there right now. So we will populate that as well as we go along through the demo. This is another thing that we usually do. We look at the running state of the system using the AT&T workflow, which is right now the only workflow that is implemented in SEBA. But again, there are no instances of this workflow because we really haven't brought out anything. But there is a whitelist that is populated, and if you remember, the requirement was to do top-down provisioning. And but the SEBA system also discovers things bottom up. So this is where the two meet through the whitelist. So if an ONU gets discovered in the system and its serial number doesn't match what has been top-down configured, or its location, for example, the PON port on the device, on the OLT device, does not match, then the system will automatically disable that ONU, won't let it be part of the network. Okay, so what I've done is the same iskratel as well as that alpha ONU. That alpha ONU, for some reason in our system, has a serial number that says Broadcom 222, but really doesn't matter. So I've configured both the alpha as well as the iskratel ONU on the system that's going to show up on this particular PON port ID. So the whitelist is the only thing that is being populated right now. There are a few other things that I'm going to show you. Again, this is where we configure top-down our subscribers. Again, there's nothing in the system right now, but this is all the same as in SEBA 1.0. But again, this is a new thing that you will see in SEBA 2.0. That is a bandwidth profile. Just like I had shown a technology profile over here, this is a new thing. It's a bandwidth profile that we will implement per subscriber. And also this is new. Again, there's nothing populated, so I'll come to that. Okay, most of all the other things are very similar to what you're already experienced. Now, so having said that, let's take a second to look at what we mean by configuring a subscriber top-down. Okay, so for us, like I said, like I showed you, a subscriber, you want to specify a location, right? That this subscriber is going to show up on this particular ONU, and this is the ONU serial number. And as I was just going through, that serial number and that ONU are linked location-wise to a particular OLT and a particular PON port on that OLT through the whitelist, right? So which is something that I had already shown you. We also want to specify the tagging, for example, the C tag and the S tag representing that particular subscriber, right? So this is stuff that you're already familiar with because this is something that we had already covered in SEBA 1.0. So what's new is that now we can associate a bandwidth profile, as upstream and a downstream bandwidth profile per subscriber. So you can express your committed information rate, how much you want to burst, excess information rate, how much it bursts, and so on, right? So this is something that I will show you when I show you that particular model for the bandwidth profile. And you also want to specify a particular service type for that subscriber. Is it a residential service? Is it a business service? Because the needs and how you configure the PON for the QoS parameters can differ depending on the type of service. So that difference, those differences in needs are specified in Volta through the technology profile. So how many gem ports or TCONs you have, what are the traffic, the priorities that you give to the different types of traffic coming from this particular subscriber depending on the subscriber's type, how you map those different kinds of traffics to the gem ports that you have available, what is your queuing policy, your scheduling policy, how you discard things in a queue. All of those things are expressed in the technology profile, and that could differ depending on the type of service that you have installed in the PON. So in this particular release, we did not get the time to actually create a model for the service type. Therefore, the subscriber right now, instead of pointing to a service type and then us inferring from the service type what the technology profile should be, the subscriber right now directly points to a particular tech profile ID. Okay. So, by the way, do feel free to interrupt me during this, and if you have any quick questions about this model or about any parts of the demo that you may be finding it difficult to understand. So with this picture, as you can see, these are the two new elements that have been added to the subscriber model. So let's look at what that subscriber looks like in one of our definitions over here. So I'm going to, let's see, look for, okay, here we go. So in this particular, the language description over here is Tosca, but that's kind of immaterial. What you want to look at is that what I'm going to send is a couple of different bandwidth profiles, okay? There is a default bandwidth profile with these parameters that I'm going to launch, what I'm going to configure top-down. And then there is a bandwidth profile called bronze that has more bandwidth allocated. So these are a couple of different bandwidth profiles that I'm going to launch into the system. And then I have specified a couple of subscribers. Here's an Iskratel. This is a subscriber that I'm going to have behind the Iskratel ONU. And this is another subscriber that I'm going to have behind the Alpha ONU. But they're very similar. So let's just look at one. As I had said before, you put in SEBA 1.0, you get to specify an ONU where that subscriber will show up. So that's this part, right? By specifying the ONU serial number. Of course, you get to specify, tagging, C tag and S tag for that particular subscriber. But here are the new items, right? So now you specify a tech profile ID. Instead of a service type, you go directly into a particular tech profile ID. And finally, you get to say what is the upstream bandwidth profile and the downstream bandwidth profile. So right now, these are both pointing to the name high-speed bandwidth profile, which actually has a name interior called bronze. So I'm going to launch this, let's see, into NEM top-down by making a REST API call. Okay, so what you can see over here is that I'm using the curl tool to make a REST API call with this ONF demo pod subscriber. So I just did that. And so now I can go back to the GUI and I can see that, okay, yes, I have the two bandwidth profiles that I put in there. One was called default, the other one was called bronze. I also have my subscribers configured. So the same information, right? The two subscribers behind the two types of ONUs, the ONU device that is specified, the C tags, the downstream bandwidth profile, the S tags, the upstream bandwidth profile, and finally the technology profile ID, which is 64. So all of that I just pushed into the system, but clearly there's no OLTs yet. So this is really just some configuration that I have pushed to the system, but nothing's actually happened yet in the data plane. Okay, so next, I want to show you what the OLTs model would be, okay? And back to, let's see. I'm going to now display, okay. Now I'm going to show you the top-down configuration for my OLT. And in this particular, so the OLT configuration hasn't changed much. It's still, this is the model, and you need to specify how Volta can reach that OLT. Of course, this is the IP address of the management plane of the OLT and the port. This says, okay, upstream from the OLT is the aggregation switch. So what's the name of that switch, and what's the port that it connects to? It's Q and Q, so the outer tag protocol ID is 8100 instead of 8888 in this particular case. This is the uplink port, the NNI port on the OLT. And very importantly, you have to get the serial number of the OLT right. Otherwise, the system won't recognize it. So, the OLT hasn't really changed much, but in the same configuration file that I'm going to upload into NEM right now, I also have this technology profile configuration, right? So as you remember, the subscribers were pointing to this tech profile ID 64. So this is that tech profile ID that I'm going to upload. What I have here, and I won't go through the low-level details, there is a wiki page that describes how the tech profiles in detail. But what I do want to highlight is that this particular tech profile has 4 gem ports, right? And those gem port attribute list on the upstream direction is shown here. There are 4 blocks, okay? And then the downstream gem port attribute list, also there are 4 other blocks. So all that QoS information about, okay, which kind of P bits in the traffic map to this particular gem port. So as you can see, the lowermost P bit and the P bit number 3 mapped to this particular gem port, which has weighted round robin scheduling. But then there are 2 other gem ports that are about strict priority and different kinds of traffic map to this particular gem port, these 2 gem ports. Okay. So there's a lot of detail on the wiki about, with a document that Sean has created, Sean Misset, and you'll find a lot of information about this, what these tech profile parameters mean.
Just real quick, are up-down items in those 2 lists? Up-down items are linked by pbit map ID, or are they linked by just array index? Or not at all?
I'm not following you.
So you showed 4 gem ports.
4 gem ports, yes.
Each gem port has an up and down aspect, correct?
Upstream and downstream, yes.
Downstream, yes. And is it just...
Are they related? Oh, okay, I get it now. So this is a template. So you will see this as part of the demo. This is the tech profile ID. What actually happens is that when this is created in Volta for a particular, let's say, ONU, you get what is what my friend Sean Misset likes to call an instance of the tech profile. Okay, in that instance of the tech profile, you actually get the the gem port IDs and the alloc IDs created for that particular instance. So let me go through the demo and I will show you. Right now, there are no IDs over here, right? There is no mapping between, there's no gem port ID. It's just the tech profile sort of, that's a template. But when it actually gets created, you will see that there is a similar block, like 4 blocks like this for upstream and 4 blocks like this for downstream, and they are related with this. The gem ports are related to each other upstream and downstream with the same gem port ID.
All right, thank you.
Okay, so yes, so as I was saying, this is an OLT configuration and a tech profile configuration that I'm now going to upload just into the NEMS database. So let's see. Okay, again, I made a REST API call into into NEM, and what I will see is that, okay, here's the tech profile. Okay, we will pretty print this in the future, but right now you will see that the tech profile has been configured, and similarly an OLT has been configured. And so, now you see that the ONUs have actually also shown up at the NEM layer. They're both enabled, they're active and reachable. And the state of the OMCI state machine is that the tech profile config download has succeeded. So this is exactly this is exactly the same information that you get in Volta. So if you go to the Volta CLI, so let's see. Oops, timed out. Let me get back in. If I look at devices over here, all right. I don't know a good way to display this. Whoops. Well, okay, it's too wide. Oh, maybe that was better. Okay, what you'll see here is here's the open OLT and the two ONUs. One of them is the Broadcom, the Alpha ONU, and the Iskratel ONU, the same state, as well as the tech profile config download success state that you see on the NEM GUI. It's basically showing the same information. Now, the same thing can be seen in, whoops. Of course, here, because of the Volta abstraction, you have now seen that Volta has just connected about a couple of minutes ago. And if I look at the enabled ports on this device, you will see that on the one side is the NNI port, that's 65536, and the other two ports represent the ONU, or rather the UNI port on that ONU. So you can see that this the name displays the serial number. This is the same serial number that we had configured. It's very important to get this right. And this is the port number that has been assigned to it. Okay. So let's explore a little bit more. What I'm going to show you is that since the tech profile config has downloaded successfully, that's the state. Let's look at what that actually entails. So I'm going to get back into my system, and let's see. Now I want to get into the etcd container. So I have to go to my cheat sheet over here to pull out. Okay, I don't. What this command is really doing is just getting inside the container. The etcd container is just looking up the name and then just going inside that to the shell script. Okay, so now I'm inside the etcd container, and now I'm going to make another call to look at using etcd control to look at the technology profiles inside. Okay, so now we're inside, and we just ask etcd what's in there. And what you will see over here, I'm just going to painfully scroll up a bit. So David, this is what you were asking, and I'm going to show that as soon as I get to the top. It's a little bit more painful going through one. Okay, so what you see over here is that this is the instance of the tech profile that has been created for the Alpha ONU. Okay, if I scroll up some more, I'll see the actual tech profile that I had configured before, and I had shown you that it had shown up in NEM. Okay, so this is the at the very top. This is my REST API call, and this is exactly the same tech profile template that I had loaded in there. But then again, it's the instance of the tech profile that I want to see for the Alpha ONU. And in this instance, what you will see is that for downstream, I have gem port ID 1024, 1025, 1026, and 1027. Okay, this is the downstream direction, and the similar in the upstream direction, I have the same gem port IDs, 10, 24, 25, 26, and 27. And also I should have the alloc ID over here that represents the TCON, which happens to be 1024. Okay. If I now look at the Iskratel ONU's instance of the tech profile, I will see different gem port IDs, of course, 10, 28, 29, 30, and 31. The same thing for the upstream, and a different alloc ID, which in this particular instance is 1025. Okay, so this is what you can see inside etcd for that Volta has created as instances of the tech profile downloaded into the OLT and ONU. Okay, now let me show you a couple of other things. So you've seen Volta, and I want to show you the flows inside Volta. So let's go and look at looking at OpenOLT, and I'm looking at the flows over here. Okay, and let me first show the flows inside ONOS. Okay, so that we can make sense of the flows inside Volta. So what you'll see over here, all that has happened is that I have configured the OLT. The OLT discovered ONUs, those ONUs were represented, and everything showed up in the system on the ONOS and NEM layers. NEM verified that the ONUs that had shown up had the correct serial number, which is why they are still in enabled state. If the ONU had shown up with a serial number that was different from the whitelist, NEM would have made a call to Volta to disable that ONU. But everything is up and enabled right now. And these are the flows that ONOS has programmed inside, inside Volta, and therefore inside this OLT. What this is showing is that you have EAPOL running. You have a couple of flows for EAPOL, one for each ONU, right? Port number 16 and 32. All it's saying is that if you see EAPOL flows, then trap them to the controller. There are a few other flows for the NNI ports as well, so that we can run some link discovery and also expect some DHCP v4 and v6 packets. So if you see, if there are any links that ONOS has discovered, it has discovered that there is a link between the aggregation switch on this port and the OLT on the NNI port. And you see two of them over here because these are just unidirectional links. So together they form a bidirectional link. Okay, and this discovery was possible because of this LLDP flow that was put into Volta. So now let's see the representation of these EAPOL flows in Volta. Okay, and that's what it looks like. So you can see that again, there is something that represents the 888E is the EAPOL ether type. And you can see that that's there for both port 16 as well as port 32, which are the two uni ports on the two ONUs. Okay, but instead of seeing one each, you will actually see 8 of them over here. So why do you see 8 of them? If you look at the flows, they look exactly the same. Okay, but there are actually differences because it's a reference to the 8 p-bits, and the p-bit mappings for each of these and the gem port mappings for each of these flows are actually different. You just don't see that on the CLI over here. I do have an intern who is working on this so that this information is actually in etcd, it's just not displayed on the CLI, and she's been working to try and get this information. So when you look at the flows inside Volta and you see 8 flows that look exactly the same, it's those missing columns that have the details about which gem ports and p-bits they are, and that's the difference between each of these flows. So you will see that in a future release, but right now what you want to see is that there are 8 of these for port 16 and 8 of these for port 32. Okay, So that's what the flows look like in ONOS, and they look like in Volta. There's a couple of other things that I do want to show you in ONOS. Okay, so if I look at the meters, okay, what I see over here is this bandwidth profile that's expressed in terms of the meters. So the first meter is meter number 1, and the rates that you will see over here reflect the CIR and EIR rates that we had programmed. So this is, so if I look at another one over here, you can see that the default bandwidth profile, so if I can also look at it here by doing a bandwidth profile default, okay, it's telling you about the CIR, EIR, and the burst size. This bandwidth profile has been mapped to a particular meter ID 1, and this is what the meter ID 1, it's called cell ID over here, looks like in the data plane. Okay, so keep a track of this, because when you look at the flows, you can see that the initial EA pole flows, they all point to a certain meter. Okay, and this is the default bandwidth. This is meter number 1, and that meter number 1 maps to the bandwidth profile default, and this is the information for the bandwidth profile default. So what has happened is that you brought up these ONUs and you've just configured the default bandwidth profile just so you, which is just enough, you know, to get the traffic coming from the ONU to the OLT and then getting trapped towards the controller. Okay, so that's that. So we are at a point now where I've explained the system about what it looks like in here. I do want to show that this is the running instance. So you can see both the Iskratel and Broadcom ONUs. NEM did the validation that the serial numbers are correct, and it's awaiting authentication. Okay, so it's ONU is of course enabled, but the authentication we are waiting, and DHCP we are waiting as well, but DHCP won't happen until we authenticate the particular RG. So let's go ahead and do that. I'm going to get back inside my emulated RG. Okay, still alive, okay. And I'm going to do an authentication by running a WPA supplicant behind the alpha ONU. Okay, so now you can see that authentication has succeeded, and you can see that over here for the alpha ONU, it has changed state of, so authentication is approved. And what happens at this point is that, you know, NEM will go ahead and configure both the aggregation switch as well as the OLT with the subscriber's information, so that ONOS, oops, sorry. If you go back and look at the flows inside ONOS, the same command as before, you will see that now there are more flows, right? For the Iskratel ONU, we're still at that EA pole state because it hasn't authenticated, but now we have the VLAN based flows for the other ONU. So you can see that, you know, VLAN 11, I think, was the C VLAN, VLAN 111 was the S VLAN. So we went ahead and programmed the data plane flows for this particular subscriber. And what you will also notice is now that it points to a different bandwidth profile, so meter number 2. So let's look at that. If you look at the meters now, we have 2 meters. There was the initial meter, which was the default bandwidth profile, and now we have this meter, which, as you can see, the rates are higher. And this now, so if you look at Volt BP, okay, so meter number 2 is now the bronze bandwidth profile, the one that we had configured for this particular subscriber. And meter number 1 was the default bandwidth profile, which was always there because we haven't authenticated the other ONU. So that's still using meter number 1, right? Whereas everything else for the for the RG behind the ONU that we have authenticated is using meter number 2. Okay, so that's really important to note, and these are all new things in this SEBA release. So if I now, you can see that the DHCP state is still awaiting. So let's go ahead and let's see. I should have a DH client running over here. I do have it, but the thing is, it has its own times between which it tries. So let's go ahead and kill the DH client and then run it again. Okay, so now I have an IP address. So 10.11.1.123. NEM should have also received the notification. Yes, you can see that it has also received the notification of the IP address. And so now if I ping, I should be able to reach the internet. And what you see over here is that for every ping that I send, I'm actually getting 3 more back. Okay, so this is a known issue in this release. So if you go to known issues, you will find that, okay, in the issue that when we use multiple gem ports in a technology profile, we do seem to be getting packet duplication in the Broadcom ASICs, and it seems to mirror the number of gem ports. Doesn't always happen, but in this particular instance, so this is a known issue. We have let Broadcom know about this in BAL 2.6, but as I explained, this release is tagged alpha because we're using BAL 2.6, which is no longer supported by Broadcom, and so there are a number of issues that we can't fix until we upgrade to BAL 3.0. But this is something that this was a decision reached sometime back, very recently actually, with the operators involved, that we were comfortable doing this release using BAL 2.6, knowing that Broadcom is not going to fix these issues in BAL 2.6. Okay, so this is one of those known issues. So back here, so we'll let that ping run. And now what I'm going to do is that I'm going to go to the other one and also run the WPA supplicant. Okay, so again, this one too has authenticated successfully. It probably does not have an IP address. I'm going to kill the DH client running over here and run it again. But before I do that, I do want to show the state that has changed in NEM. Again, authentication was approved. It's awaiting DHCP, but it has already programmed both the aggregation switch as well as, so let's look at the flows again in ONOS. And you can see now there are a lot more flows over here. And if I looked at the meters again, representing now I only have meter number 2, because if you remember, I had configured both subscribers with the bronze upstream as well as downstream bandwidth profile, right? So therefore, in this system that only has 2 ONUs, they are both authenticated, they're both in there. So only the bronze bandwidth profile is required right now. The system went ahead and removed the default bandwidth profile because it's unused. It removed the meter for it. There's only 1 meter in the system right now, and that's reflecting the bronze bandwidth profile. It went ahead and removed the unused default bandwidth profile meter. Okay, and if I now And similarly in Volta, if I look at the flows, you'll see a lot more flows using the VLAN tags, 12. This is the, the CVLAN and SVLAN for the 2 subscribers. I think in this system, they have the same SVLAN 111, but they differ by the CVLAN. One is 11 and the other is 12. And again, you see that for each flow in ONOS, it actually became 8 flows in OpenOLT, just because of the different, the P bits being mapped to each flow and the gem ports that they point to. Okay, so having said that, let's see, we still haven't done DHCP on, so let's see, let me do DHCP on the Iskratel ONU. It got an IP address. The NEM should have seen that. Okay, NEM does see that. And so I should be now able to reach the internet, and yes, I can. Okay, so what you see over here is that the Iskratel ONU does not see any duplication of packets, but as you can see, the other ONU is duplicating. So like I said, you see it. I see it when I use multiple gem ports. I see that sometimes show up on the Iskratel or the alpha, or it's the other way around. So that's one of the known issues in this release. So very quickly, I do want to take a little bit of time to talk about some of the other known issues. Mainly, they are related to flow deletion. You will run, there are many ways you can trigger this flow deletion, and that leads to an irrecoverable error in BAL. And at that point, the only course of action is to reboot the OLT. So you can trigger this in many different ways by either, say, enabling or disabling the ONU, or by making the remove subscriber call. You can see that in a system where you have even a single ONU or multiple ONUs. Empirically, I do feel that when there are multiple ONU scenarios like we have over here, it's much easier to trigger this issue. You can see it with single gem ports as well as multiple gem ports and so on, right? And so because of this, it's not a very, you should be able to, in a running system, you should be able to change the bandwidth profile for a particular subscriber. Let's say the subscriber has upgraded their service and you went from whatever, having 100 megabit service at home to a gigabit service. So you should be able to change the bandwidth profile. But right now, with the use of BAL 2.6, it's unreliable because you kind of have to remove some flows to change and then reprogram some flows, and then the removal and reprogramming process, you hit this error in BAL, and then it really just doesn't work anymore. Okay, so that's all really I had in this particular demo, and I'm happy to take any questions that you may have. The main thing that I just wanted to point out is that this demo is very similar to demos that we had done before regarding whitelist and the particular tag and how we're doing uploading models for the OLT and subscriber. But really the key thing was bandwidth profile, and it's reflecting in the meters that you use in ONOS, and the tech profile and the instances of which that get created in Volta. So hopefully that demo was useful, and I'm happy to take some quick questions. We're already at the top of the hour, but happy to take a few questions.
Saurabh, so on the meter, the default meter bandwidth got deleted, right? So if there's a new ONU coming up, is that new default meter band is coming back?
Yeah, it'll come back. That's right. It'll come back. If there were more ONUs in the system for the RGs behind which have not been authenticated, then that meter band for the default meter would not have gone away. But even now, if you introduce a new ONU into the system, dynamic, so the OLT discovers it, and then again, that default meter will come back.
So what's the purpose to delete it?
It's just cleaning. In this particular instance, there is no need for it, so the system just cleans it up.
Okay. So potentially, so the system will also clean up if everybody upgrade to a different, let's say, to silver, so the bronze meter will
go away. That's right. Yeah.
Will go away.
Yeah.
Okay. In a production system with many OLTs, many ONUs, do you see a risk of flapping around this type of situation? Because in a production system, it's likely going to be needed, not needed, not needed, or any insights or thoughts about that?
I'm not sure. I mean, okay, yes, it's dynamic, but it's not like I change my bandwidth every second, right? Or change my bandwidth subscription every second or something. So I don't know. Okay, but in a production system, you'll also be doing this across, say, 1,000
multiple
subscribers.
users, right? And that's the issue.
Yeah, it's possible. But we won't know until we try it, and so that's something to keep in mind if for the future. Yeah.
Again, so that default, I guess that default, the EA poll is using that default to do the EA poll. Is that correct?
Yes, but once I put in the subscribers bandwidth, I have even the EA poll would use say meter number 2, which is that bronze bandwidth profile. So earlier it used, when it first comes up, so let me scroll back to okay, so here I hadn't authenticated. It was still using the default VLAN, which is 4091 in this system, right? So this ONU, the EA poll was used with default VLAN and the default meter number 1, which was the default bandwidth profile. But once things got authenticated and I programmed the data plane flows, the same EA poll flow now uses the subscriber C VLAN, which is VLAN ID 12, and now it uses the subscriber's upstream bandwidth profile, which happens to be meter number 2.
Okay, I think that there's because the EA poll usually have a higher, P-bit priority or something like that. So we can talk about this offline.
Yeah, so that P-bit priority you see is not reflected over here. That is actually reflected in the technology profile, right? So, in the technology profile, the P-bit from the RG will very likely be coming in with a certain P-bit that has been mapped. Mm-hmm. So maybe this is the high priority P-bit that's going to be in the packets of the EA poll packets, and then that will get mapped to the strict priority gem port. Okay, so that all happened through the tech profile. ONOS was not aware of the P-bit mapping because that's expressed in the tech profile. So that one EA poll flow that ONOS sent actually became, say, 8 flows, each with different P-bit mappings to gem ports. And so when your RG actually sends that EA poll, it's not going to have all kinds of P-bits, right? It's going to have one of these, and therefore it'll end up in the in this particular gem port, which has the strict priority. Did that make sense?
Yes or no, but no, we can talk offline. I think that's
I mean, very in this demo, I went really into the weeds, so to speak, giving very low-level details of the flows and the meters and how they all translate and how the tech profile comes in and all that. In many, so but don't be alarmed with all these details. And from on a high level, from the operator's point of view, these are the things that you configured, right? You configured a certain bandwidth profile, a certain tech profile, a certain tagging for a particular subscriber, and where it's supposed to show up on. And that's it, right? After that, the system took care of it. I mean, I manually went ahead, because I have emulated RGs, I manually went ahead and did EA poll and DH client, but in a real RG, those things should happen automatically. And all the steps that I walked through about how NEM sees things getting approved, sees, does its programming of the data plane flows, sees things getting IP. All of these things should just happen automatically. So,
yep.
So just different perspectives about getting into the weeds and what happens at the high level. Any other questions?
Hi, Sarah. Did you have a chance to test if the bandwidth profiles are applied actually to the packets? Like, did you test any using iPerf, for example?
Yeah, actually, it's funny you say it, Sarkar. It's actually NetCF folks who were part of the tech profile brigade that did that analysis. Also, I think Girish had done the same thing from Radisys, as well as, let's see, I'm forgetting his name.
Yeah, I heard it's not.
Sriju from Jabil, right? So they've all tried using different pbits and have their through iPerf. Yeah, you were trying to say something, Sarkar?
Oh, I just wanted to say, I know it's not working, so I wondered if you have it work it.
So no, I don't think, no, it was working. But you are, what you may have heard was multi-TCONT, which is what Turk Telecom is trying out right now. Okay, multi-TCONT scenarios, I'm not sure. I haven't heard the latest, but this demo was done with a single TCON and multiple gem ports, and their respective pbit mappings. And back in the tech profile brigade days, about a month ago, I have data from Sriju as well as NetCF folks about. Do you still have that, Sean Mizet? Do you have that information regarding? We had that whole discussion where we were looking through the iPerf data.
Yeah, I probably have it in my email, but I'll have to go back and look.
Yeah, Saurav, I mean, if the bandwidth profile data is in the documentation which we developed. If you remember,
the iPerf results.
Yeah, it uses the iPerf. Yeah, using iPerf. It doesn't show the technology profile, but we have the results for the bandwidth profile in the documentation.
Okay, I have to find that documentation. I know I do have that somewhere.
Should be in SEBA.
Oh, that's not that. Okay.
So
yeah,
we're going to need to get out of the conference room here on this end. So
oh yeah, that's right.
You're wrapping up already.
So okay, thank you for this, and thank you everyone who came and gave us some extra time and dealt with the technical difficulties. And I'll be posting this to YouTube. Thanks everyone. Talk to you next week.
Thank you. Bye.
Thanks, Rob.
Thanks, bye.